Okay, my name is Nigel Pinnell. This is my standing wave project. Got a tape ruler, graph calculator, and notebook, paper, and pen, obviously. Um, Start the whole thing out. Definition of a standing wave. Standing wave is basically a static wave, also like a stationary wave. Um, Always remains in a constant position. And with standing waves comes nodes and antinodes. Nodes and antinodes are basically uh, in the actual standing wave. Um, the nodes are like the points that don't move. Like as the wave goes up and down, there are points that actually don't move because the lines are always changing, and that's where they just are. And then antinodes are on the top of the crest. As the wave goes up and down, they're actually the points that move the most, which is obviously the complete opposite of a node. In a recording studio, um, all those things are bad. Obviously, standing waves are bad because you can get noise cancellation, or certain frequencies will get canceled out or anything. And then obviously you're not getting a true mix or true representation of what you're actually recording. When you're trying to get rid of these kind of things, a lot of people have like sound deadening or like bass traps or anything like that, or any sort of way. A lot of people will change not the dimensions, but change some sort of shape in the room so that the waves aren't bouncing off each other like they want to. So I guess next thing I should measure the room. So I'm gonna do that. Okay, so the room is 7 foot 5 inches. So that is 7.41 feet tall. Along the floor, it's 7 feet 1 inches. I almost forgot that. 7 feet 1 inches. So, which would be 7.08 feet. Then I gotta do this way. Okay, so and the length of the floor, so long ways, I guess, is 12 foot 11. So 12 foot 11, 11 divided by 12 is 0.9111 or 16. So 12.1 feet long. So now have these formulas here. Obviously, this is the original one, and this is the one we're going to be using for because we're trying to find the frequency of the wave in the actual room. So our three frequencies here. Let's do some. Okay. So 7.1 or 41 rather, and that is we want to do the speed of light or speed of speed of light. So 1,130 divided by 7.41. That gets me 152.49. So obviously with sig figures, obviously we have to get rid of some numbers here. So that'll turn into 152.5 hertz. Our next one, I have the dimensions. We'll do tall. So that would be 1,130 divided by, that was the 12-foot one, 12-foot 9 one. And that brings us to 87.53 because of sig figs hertz. And then we have our final one, which is 7. Let's see. Yes, which would be wide, which is the floor. So then we have 1,130 divided by 7.8. No, 08. Excuse me. And that gives you 159.6. And with sig figs, that's correct, so that works. And that's hertz. So for our standing waves of the room, here are our 3 numbers. I'll just read them out to you one more time. So let's see, long waves we had 87.53 hertz. The standing wave wide, which would be this way, was 159.6 hertz, and the tall was 152.5 hertz. And that is everything. So yeah.